Hi! Last time we explored features of Connectome Workbench WB View when a brain volume file was loaded. In this video, we'll explore some viewing features of WB View when we load surface files and brain maps, and show you how to save a basic scene file. First, let's launch WB View from the terminal. We'll again skip the splash screen to open data from the main WB View GUI window. We're going to open several brain surface files in the GIFTY format from the Macaque Yerkes 19 group average dataset. Again, the link to get this dataset is in the description section below the video. Looking at brain maps on a variety of surfaces allows you to better interpret the data in the context of the brain structure, while also being able to view data that is sometimes hidden by the brain's folding. This opens a montage view of the lateral and medial sides of the group average left and right hemisphere surfaces. Here in Montage Selection in the toolbar, this checkbox indicates that we're displaying the group average mid-thickness surfaces. Clicking on this field, you see all the left hemisphere cerebral cortex surfaces we loaded are listed and can be selected for display. So here I'm selecting the peel surface for the left hemisphere, and then on the right, I'm selecting the inflated surface. The checkboxes at the bottom control which views of the displayed surface are shown. When you toggle these, the zoom adjusts to maximize the view of the displayed structures. For comparisons between surfaces on the same hemisphere, you can turn on a second row of left and right surfaces, here showing the mid-thickness surfaces again. The selector at the top right changes the display layout of the selected structures. This flexibility can be really useful when you're building up the display of several tabs in Tab Montage View for comparisons between many brain maps, which we'll show in a later video. If you have flat maps or cerebellar surfaces loaded, you can set up display for them by changing this selector. Moving your mouse to the viewing area or viewport, click and drag your mouse to turn the surfaces displayed. Zoom by holding down the Command or Control key and click and drag the mouse up and down. Also, if you have a mouse scroll wheel, scrolling forward zooms in and scrolling back zooms out. Pan the image by holding down the Shift key while you click and drag your mouse. You can reset the rotation, zoom, and pan with the Reset button. Commonly used orthogonal rotations can be applied using the DV, dorsal ventral, AP, anterior posterior, and LM, lateral medial buttons. The Custom button, Create and Edit, opens a dialog that allows you to set more precisely what rotation, zooming, and panning you're currently displaying. Custom views can also be saved here to apply to brain structures loaded in future from the Custom button. Down here in the Overlay toolbox is where we set the data maps to be displayed on the surfaces. We don't see any data files listed because right now all we have loaded are base surface structures. Let's load some brain maps and look at them displayed as overlays or layers on the top of the surface. The structural spatial maps we're opening are dense scalar files in SIFTY format that have a data value for each surface vertex across both left and right cerebral cortex. With these files loaded, we see the file fields in the Overlay toolbox are populated. If we click on the File field, you can select from the loaded files. I'm selecting the Average Bias Field Corrected Myelin map as the first or top layer and clicking this top layer on. This is showing the distribution of myelin over the macaque cortex, taking the ratio of the T1 weighted and T2 weighted signal intensity, with the warmer colors indicating higher myelin content and the cooler colors lower. Here you can immediately see the difference between viewing the myelin map on the peel versus the inflated surface, where some of the map is hard to see, particularly in the peel surface due to the folding. Viewing this type of map on the very inflated surfaces helps to see the detail. Let's set the second layer to the average surface curvature or folding, and the third layer to the average cortical thickness, corrected for surface curvature. The maps we've toggled on with these checkboxes are stacked as layers on the surface. Turn off the layers on top to reveal the layers below. you can add layers or move the layers in the stack with the construction button. Turn on a color bar for a displayed layer with this color bar button. Click the wrench button to open overlay and map settings, such as selecting palettes for map display, thresholding, or color bar settings. The options here change with the type of data file you have in the layer. Now that we've loaded files and set up display of the data, it's useful to save all these settings in a Workbench scene file so that the next time we open WBView, we can more quickly load the data and pick up where we left off. Click on the clapboard button at the top right of the GUI to open the Scenes window. First, we need to create a scene by clicking the Add button to the right. A scene will save the current state of your WBView session, including a record of whatever files have been loaded and all view settings. Add a name for your scene. You can also add a description here, which is helpful when you share a more complex scene with others. Now we need to save the scene to a scene file. Click the Save As button to change the default, untitled scene file to a more meaningful name, like Macaque Group Average. Also, notice where your scene file will save and change the path if needed. We recommend saving scene files in a directory one level above the data files so that they're easy to find. We can go back to the viewer and make changes to the displayed orientation, surfaces, or layers. If we want to return to the settings we just saved in the scene, back in the Scenes window, we just double-click on the scene or click the Show button to reload it. If you make changes that you then want to save to the scene, click the Replace button. Note that the fact that you made a modification to your scene is indicated by the red yes up here. This warns you that you need to resave the scene file before closing WBView to keep those updates. Click the Save button. Now we can close WBView, reopen it, and open our scene file to get back to where we were. That's it for this video. Next time we'll explore a more complex scene file to show off some more data types and display features in WBView.